Okay, welcome back students. We're going to talk about inverse sine function. Now there is actually a crucial definition we need, so let me pull that out. Inverse sine function is this. Basically, you have the inverse sine is y equals arc sine of x, and this happens if and only if x equals sine of y. Okay, that is defined as if you switch it, or y equals sine of x. Yeah, and so its domain is -1 to 1. I'll write this on, I'll blow this up in a second. And its range is from negative pi over 2 to pi over 2. Okay, we'll write this again, so don't worry if you didn't catch that. If it's too small, we will write it again. I'll blow it up just for your sake. Okay. Okay, so that is the key ideas. So if there's a value arc sine of x equal y, if and only if x equals sine of y. Basically, they need to be inverses. Okay, so arc sine of -1/2, sine inverse of root 3 over 2, sine inverse of 2. Okay, these are all identical concepts. Okay, inverse does mean this sign right here, -1 of 2. So let's transition. Okay, arc sine of -1/2. So what you do here is you are actually going to remember that if this is our y value, so arc sine of y equals x if and only if y equals sine of x. Okay, so this in this case is going to be the y that we get from sine of x. So this -1/2 is going to give us a side length. Okay, so what you could think is you can think sine of what equals -1/2. Sine of what equals -1/2? Well, sine of pi over 6 of negative pi over 6 equals -1/2, right? Not positive, but -1/2. So negative pi over 6. So then what you do is then you find out that the answer is going to be arc sine of -1/2 parentheses. It's going to equal negative pi over 6. You can actually leave it as negative pi over 6 because in this case, this is the domain and range of arc sine. Okay? Okay, what about sine inverse of root 3 over 2? Great question. Okay, so sine inverse is the same thing of root 3 over 2. So then what you do is you do root 3 over 2 equals sine of x. So what does x equal to? Okay, so sine of x will then equal root 3 over 2. So x then equals pi over 3. Okay, now we know this from our unit circle. Okay, so then our answer is sine inverse equals pi over 3. Okay, let's do one more, and then we'll get into the other questions. Okay, so let's do this real quick. Sine inverse of 2 will give us nothing, because when can 2 equal sine of x? Well, there's actually never a case, so there is no answer. Okay, this has no answer. Okay, So it is outside of the domain or range of sine. Okay? Okay, sketching the graph. Sorry, let's go up. So sketching the graph, if you plug it in, pi over 2 for y, sine of y, is going to give us this x, so arc sine of x. So y is going to equal what arc sine of x is, okay? So there's our x values we're plugging in. Here's our y values we're getting out. So this gives you an easy comparison between what our x values are and what our y values are. So if you couldn't read that, here, let's pull it up real quick. Okay, so that's our x and our y values for the function y equals arc sine of x. Okay, key concepts. Definition of trig, inverse trig functions. Y equals arc sine of x if and only if sine of y equals x. That's what we talked about before. This is going to show us three different functions, our cosine, our tangent, and our domains, what our domain is restricted to, what our range is restricted to. So notice, arc sine and our cosine are restricted to -1 to 1. That means if you go beyond that, they don't work. Their ranges are different. So arc sine is only negative pi over 2 to pi over 2. Our cosine is 0 to pi. Our tangent doesn't have a restriction on the domain, but the range is restricted to be greater than negative pi over 2 and less than pi over 2. Because if you go beyond it, it won't have an answer. Yeah, these are our graphs so that you can see how our functions are restricted in domain and range, restricted in domain and range. Okay? Same thing, restriction not in domain, but definitely in range. Okay? Okay, those are going to be crucial concepts for the future. Okay, let's look at finding exact values. So, exact value of cosine of pi over root 2 over 2. Let's do some of these problems. So arc cosine of root 2 over 2. Now remember, this is just the same thing as cosine of x equals root 2 over 2. So what does this value equal to? Well, then x will equal to pi over 4. So you just plug in pi over 4. Okay? Cosine inverse of -1. This is going to be the same thing as when cosine of x equals -1. That's in this case going to be not 0. That would be a positive 1. The -1 would be pi. Okay? Okay, so that's two of the answers. So let's look at the next two. Our tangent of 0 and tangent inverse of, so this will be the same thing as when tan x equals 0, and this is just crucially 0. Okay? Tan inverse of -1, that's going to be when tangent of x equals -1, which the only time that happens is negative pi over 4, because one of the cosine or sine is positive, the other one's negative. Okay, so that's how we answer exact values. Now remember, I reset it to think tangent of x equals some side value, and then I look for the angle. So basically we're always going to find theta from this inverse. Okay, inverse functions will give us our theta. Okay, why is that important? Because we're going to talk about composite functions now. Well, you could approximate some of these questions with calculators. That's not really that hard. It's pretty easy to plug in. Just plug it in into your calculator. Make sure it's in radians. Inverse property. Okay, so if so this basically tells us if -1 is less than or equal to x is less than or equal to 1, then sine of arc sine of x is equal to x. Arc sine of y equals y. Same thing for cosine. Arc cosine of x equals x. Arc cosine of y equals y. If x is a real number, so this is restricting our domain and range just so that you can find the actual inverses of the functions. So if x is a real number and negative pi over 2 is less than y, is it less than pi over 2? Then tangent of arctangent of x is equal to x, and arctangent of tangent of y equals y, okay? That is that you can reverse these. So, okay, let's look at these examples. Now, tangent of arctangent of -5 equals -5. That's pretty simple, pretty straightforward. Let's actually get into this because it's easier to actually just write it in this. Okay, and arc sine of 5 pi over 3 is just going to equal 5 pi divided by 3. Okay, cosine inverse of pi is just going to equal pi. Okay, pretty straightforward. That's how you do those. Okay, you just inverse them, cancel out, and then you get the inside. Now what about different ones? Okay, these ones you're actually going to have to think about it in a very different way. So, tangent of arc cosine of 2 over 3 and cosine of arc sine of -3 over 5. I'm going to show you really quick, hopefully in 1 minute, how to do this. Apologize for the video length. So this is tangent of arc cosine of 2 over 3. Now arc cosine is actually going to give you the ratio of the sides based on the angle. And so this is the theta that it will give you, and it will give you adjacent over hypotenuse. So we need to find opposite. So this is 9 minus equals the square root of 5. So then this is going to be the ratio inside of this angle. But tangent gives us opposite over adjacent, right? Our answer is going to be opposite over adjacent, so our answer is going to be root 3 over 2. Root 5 over 2. Root 5 over 2. Okay, that's a simple way of doing it. So, again, the inside gives us this angle. Tangent of an angle gives us side ratio. Okay? So, last one, cosine of arc sine of -3 over 5 is going to give us, so this is going to be side length. I'm just going to draw it this way. This is theta. This is -5. Sorry, not -5. This is -3. And this is 5. So then if you do it, 25 minus 9 equals 11. Sorry, equals 16. So this would equal 4. So cosine would be adjacent over hypotenuse, which would equal 4 over 5. So that would be our answer. Okay. Okay. In example 7, we're going to skip over. We'll come in class and talk about it. Okay. I'll see you in class. Bye.